The most general form of the Bayes theorem is the one that uses events. I'm going to present this form of the theorem, and then I'm going to explain the theorem in itself, and I'm going to use a grid that I developed in order to try to help the understanding of the Bayes theorem. So in the most general form, we've got events A and B, and the theorem tells us that the probability of A being true or having occurred, given that B is true or occurred, equals the probability of B being true given that A is true, times the probability of A being true divided by the probability of B being true. In some instances, it's useful to consider that this Bayes theorem is a shortcut for 4 equations that take into account the 2 possibilities for events A and B. Event A could be true or false, and event B could be true or false. So that's represented on the right-hand side in yellow by replacing the generic A by plus A when A is true and minus A when A is false, and plus B when B is true and minus B when B is false. So on the top row, it would be the equation tries to calculate the probability of A being true given that B is true, which is the traditional form of the generic form. But we can also consider the probability of A being true given that B was false, which is the second row, probability of A being false given that B is true, and finally the probability of A being false given that B is false. So typically we are given the information of the probability of A, and we are given the information of the probability of B given A. So we need to find out how to calculate probability of B, which is not easy. So in this case, the probability of A, we have that the probability of A being true is 0.6, and the probability of A being false is 0.4. And these 2 probabilities should add to 1. Now the probability of B given A, we've got 4 options. Probability of B being true given that A was true is 0.8. Probability of B being false given that A is true is 0.2, and this should add to 1. Then the probability of B being true given that A was false is 0.3, and probability of B being false given that A is false is 0.7, and this should add to 1 as well. Now we are going to replace the information in the theorem in the grid below. So we are going to put the probability of B given A, which are 4, and we've got a grid of 4. Then probability of A, we've got a grid of 2 cells, so we have 2 values to add there. Now then we are going to have the probability of A given B on the left grid, and again we've got 4 cells, so we are going to put 4 values there. And then we are going to use calculate the probability of B given A times probability of A, and we put in the cell between probability of A and probability of B given A. This will allow us to calculate also the probability of B, which would be the sum of these 2 columns in the green grid, and this will give us the probability of B being true and the probability of B being false. So in this grid, the top row is A being true, and the bottom row is A being false. And the columns, the left column indicates that B is false, and the right column that B is true. So let's start replacing. Probability of A being true is 0.6, and probability of A being false is 0.4, so we take that information from above, and now we need to indicate the 4 values for probability of B given A. So probability of B being true, given that A is true, should go on the top right corner, because that's where A is plus and B is plus. And probability of B being false, given that A is true, should be on the left top corner, because that's where B is false and A is true. Probability of B being true, given that A is false, should go on the bottom right corner, because that's plus for B and minus for A. And finally, probability of B being false, given that A is false, goes on the top left corner. We need to check that these two, 0.8 times 0.8, 0.2 times plus 0.8 is 1, and 0.7 plus 0.3 is 1. And we also check that 0.6 plus 0.4 also adds to 1. Now we are going to see the concept of likelihood. So the likelihood coincides with probability of B given A, but instead of looking at this grid horizontally, so 0.2 and 0.8 for A plus and 0.7 and 0.3 for A minus, we look at it vertically. So we are saying here the likelihood of corresponding to minus B. This should be understood like this. Still, we want to see if B is false, what's the likelihood of A being true and A being false? It would be 0.2 and 0.7 respectively. Now, likelihood of plus B indicates if B is true, what's the likelihood of A being true, which is 0.8, and A being false, which is 0.3. So, importantly, you can see that these values do not add to 1. That's why this is called likelihood and not probability, because anything that is a probability, the sum of the probabilities of the sample space must add to 1. So now we are ready to calculate the 4 values of the numerator of the Bayes theorem. So we have to do the 0.6 times 0.2, that gives us 0.12, and 0.6 times 0.8, this is 0.48. We do the same in the bottom row, 0.4 times 0.7, it's 0.28, and 0.4 times 0.3 is 0.12. Now we want to check that these 4 values in green must add to 1, and that is what happens. So now we've got the numerator of the Bayes theorem. Now we are ready to calculate the probability of B. And the probability of B being false will be the sum of the 2 values on the left column of the green grid. And the probability of B being true would be the sum of the values on the right column in the same grid. So in the left column, we've got 0.12 times plus 0.28, that's 0.4. And on the right column, 0.48 plus 0.12, that's 0.6. And we check that 0.4 plus 0.6 is a probability distribution, so it must add to 1, and it does. So now we've got the last step, which is to calculate the posterior, which is the probability of A given B. And we do that by doing what the equation says, 0.12 divided by 0.4. So we've got probability of B given A times probability of A divided by probability of B. So that's 0.30. So now we need to do the same with 0.28 divided by 0.4. That's 0.7. And these 2 values must add to 1. So 0.3 plus 0.7 should be 1. And we do the same with the values on the right column of the green grid, 0.48 divided by 0.60, and that's 0.80, and then 0.12 divided by 0.60, and that's 0.20, and 0.80 plus 0.20 should add to 1, which it does. Let's now return to the original argument, which was to try to calculate what's the probability of A given that B is true. So we consider that B is true, and we started with a prior for A being true, E being 0.60 and false 0.40, and now we observe that B is true. The likelihood is 0.80 for A being true and 0.30 for A being false, and the posterior distribution 0.80 for A being true and 0.20 for A being false. And the probability of the data is 0.60.